so what I'm going to do is put the hands down, and I want to go to Mark Sokol now, and Mark can give us some lab updates. Mark?
Hey, see ya.
Thanks again. And let me see. Mark's being a little slow. Maybe he stepped away. What we could do instead, we'll give him a couple more.
Okay.
There we go.
Are we ready?
Yes. Updates, sir. Please.
One
Please,
second.
please,
One
please.
second. I can't hear anything. Can you guys hear me?
Yes, we can.
Yeah. How?
Hooray, it's Mark.
Okay, perfect. I can hear you now.
Okay.
Okay. Yes, that was quite a presentation from Tim and then George Hathaway showing up. So we have some new updates here from the lab. One of them happened during APEC today. We just received in some new amplifiers from Sandia Labs. There's 2 of them on the pallet over here. These are 200-watt units, and they cover like literally the entire RF spectrum from 400 megahertz to 12 gigahertz. I was most interested in the 7.6 to 12 gigahertz unit over here. And as luck would have it, it was broken, and we're trying to figure out why it wouldn't be turning on. And just about 2 hours ago, we found some of the transformers on the low voltage section had come loose off of their board, so they weren't given the proper voltage. So we had to solder those back into position. The switches on the front panel were mostly all broken, so those need to be replaced as well. But right now we are getting that red lamp over there, and then eventually the standby lamp will turn on as well. And so it does seem to be working, and there's only 250 hours on the traveling wave tube amplifier, so we should be good to go with this unit. And this is going to be running Alzafon hopefully sometime next week or this coming week. Here's another unit that I had open just for comparison, because all the low voltage and high voltage boards and everything are pretty much identical between these units. That helped find the problems. Aiden Schaefer over here helped out and punched a hole inside the Faraday cage over there. You see that large hole down there? That's where we're going to be feeding in waveguide for our higher power experiments. So the amplifiers can sit outside. We also got a new computer for the lab. This is for getting in all the data and signals and all that kind of stuff. It's all going to be fed into a lab, this computer with LabVIEW on it. There's also live video feeds that are going in over here. So all the information is going to be plastered along these 2 screens as we're running experiments. What else we have going on over here? Aiden Schaefer has his Manellis device, which he's going to give us a little rundown on.
Yeah, so I started working on the original part, or what Mark 1 is up here, and these are some of the coils which are similar to here. This does have the conditioned ferrite.
Can you just give a rundown what the Manellis device is?
It generates it's using the Aharonov Bohm physics. So in the conditioned ferrite, which I haven't gotten.
What does it do with the Aharonov Bohm physics?
Thermoelectric conversion is what
Bingo.
Dr. Ahern has seen, but Mark doesn't have a full grasp of the physics, which is partially in the ferrite. Let me get the viewing film out. Coils upon coils upon coils. So although that looks pretty dirty, this is preconditioned ferrite, and then I've got to finish getting this coil. I'm not happy with this one, but little by little, I'll probably make another one. And then you hit it with high strength or high voltage. And then it's been reported that it'll start getting a circulating oscillation within the ferrite. I'm not happy with building on the square and the round, so I switched over to the round.
And then you get the oscillation in the ferrite. What happens next?
Well, then it starts, after a while, the oscillation starts, the circuit's tuned and it kicks out every voltage spikes over 180 volts into the system. So it's the original inventor modified the Bedini schoolgirl circuit and turned it into a solid state device. So anyway, this is Mark II. I still have to finish doing some this is my second attempt at it. It's more of a test bed. And then here's the start of a magnetic component. So I still have to degauss this via thermal methods and then create a coil, or maybe this coil actually does work on there too. And then whack and get the exotic state of matter going on in the ferrite. So this one's allowing me to work on the round. You know, I'm working on the round is helping me to work through the squirrel's nest of the Manila circuit, because I have the original technician's report of it from 2012 by Graham Gunderson. So thank you, Dr. Vallone, for keying me in. But eventually, you know, nobody else in the group is working on pulling in the vacuum. So this system does do that. I've found that in 2011 in the Tesla Tech conference, there was a Kohler, there was a German guy back in the 30s by the name of Kohler that had a similar circuit. So over the last, I don't know, well, from the 30s and then Arthur Manellis, you know, there have been a couple people that have been able to have a circulating circuit that produces more electricity, or it changes the domain and is able to pull in electricity from around.
From
So
thermal energy. And what part of the circuit is the one that cools down?
it's within the ferrite, or actually
The ferrite being the center disk over there, right?
right, yeah, or over there. But the Dr. Ahern, when he was monitoring Arthur Manellis's device, they had a whole bunch of thermocouples spread out in the trunk where he had his system set up, and as it ran longer, it became cooler within the trunk. So
Trunk of the vehicle, that is.
yes.
Okay.
And then the car, you know, after, you know, without being plugged into the grid, it was an electric car, and they had it under monitoring. And when they plugged or started the monitoring process, the battery was at 69%, and they came back a couple days later, and the battery was up at 83% without Arthur coming in. And you can look on the Tesla Tech conference. I'm sure Steve Elsick will put it out on YouTube eventually, or you can look through Dr. Vallone or approach me, and I'll be happy to talk about it. So just making gradual progress, yes. But the real physics is working with the ferrite and improving this. And then once I get this whacked, it'll have that exotic state of matter in it, and that's what's doing the work. So,
Or the conversion.
the work, yes.
So here, that gives you pretty much a rundown on what's going on. These two units on the bench, we still haven't powered them up yet. Also, for those of you who don't know, we used to be a hybrid battery shop, and some friends of mine are taking over that business. So there's a lot of free space over here. They moved it over to another building. There's enough space in here to play tennis probably right now. So we're clearing out the lab for larger and better things. Also, I got hit by the COVID, and that knocked me out for a couple of days, and just still recovering from that. But this is basically what we have going on over here. We just managed to get this running just about an hour or two ago. And I'm waiting for one waveguide piece to give us a twist, because right now it's at the wrong plane. And then we'll be able to hook it up inside the Faraday cage and see what happens with Alzafon. We did run Alzafon at 20 watts. That's 20 watts traveling wave tube amplifier. And we measured about 1 watt of power being received in a little saltwater test article inside of the waveguide. And when we tested that using the aluminum samples, there was a little bit of a wiggle on the scale. We're using an analog scale this time, and just putting a camera on that so we can see what's going on.
It's
Um,
upgrade the lab.
And that's why we're upgrading to LabVIEW and all these other software and hardware upgrades, so we can get much more accurate views on what's going on. But that's basically what's happening here at the lab. Oh, one other thing. This is the gyroscope contraption. Mike Gamble, if you're watching, there's two of these that are completely built, and they have two servos on each unit. There's also the 4-inch gyros that are just about complete over here. We got the motors for these coming in soon. Here's here's one with more material removed, so you get more weight on the edges. Now, these are the 4-inch gyros, 3-inch gyro systems already set up. So that's something else that we're working on. We're just looking for somebody to do the software programming for this project to finish it up.
Awesome. So Mark, that's it for the update then?
Pretty much, yeah. I think Jeremiah might have some stuff to update. He's
Let
He's
me
been
see.
working on-
Jeremiah, are you with us?
he might not be.
He's not here. Nope. Mr. Reese is, but not Jeremiah Pop.